Assalamu alaikum. I am Dr. Saeed Ali Mardanatni. Welcome to my channel. In this lecture, we will learn how we can evaluate line integral over the space curves. But before that, we must know what is a line integral. In single variable calculus, you were used to of calculating area under certain curve with the help of a single integral. Now, here, we will use single integral in a different way. Please imagine if you have to calculate mass of a thin wire along a curved path, then how you can calculate it. And for this purpose, you may imagine if you have a spring in your ball point and you have to calculate its length, how you can do it. Similarly, if you have to calculate work done by a force acting along a curve in three-dimensional space, just like this blue curve, then how you can do it. For this purpose, we have the concept of line integral. How we can calculate a line integral? If we have to integrate a continuous function f of x, y, z. In some cases, just like I have given example here, this function may be a force function, or this function may represent the mass of a small part of this curve or the small part of the wire. Now, if we have to integrate a continuous function f of x, y, z over the curve C in three-dimensional space, then first of all, we will calculate a smooth parameterization of C. R of t is equal to g of t I plus h of t j plus k of t k. Here g of t is the part along x-axis, h of t is the part or function along y-axis, k of t is a part or function along z-axis. Then we will evaluate the integral as integral over the curve C, f of x, y, z, ds is equal to limits from a to b, f of g of t, h of t, k of t, multiplied by v of t mod into dt. Please note that in this example or in this formula, the limits of t are a to b, where t is our parameter, a is the starting point of the curve, and b is the ending point of the curve for your calculation. Also, in order to transform our integral in the form of parameter t, we have replaced the value of x, y, and z in the form of parameter t. And v of t here is equal to dr over dt, means derivative of r of t with respect to t. So in the process of line integral, we have to follow two steps. Since we have to multiply these two things, f of g of t, h of t, k of t, and these values g, h, and k are coming from r of t, so it means we will convert our function in the form of t with the help of r of t. And the second thing, we have to calculate v of t mod, which is actually the derivative of r with respect to t. So we will follow two steps. In the step number 1, we will calculate v of t mod. In step number 2, we will transform our force function in the form of parameter t. And after these two steps, we will substitute these values in this line integral for the given limits, and then we will calculate this line integral as a step 3. Now, after knowing the basic things, what is the line integral, what is its formula, we have to know one more thing, and that is parametric equation of straight line segment. In three-dimensional space, the equation of straight line in parametric form is x is equal to x1 plus t into x2 minus x1, y is equal to y1 plus t into y2 minus y1, z is equal to z1 plus t into z2 minus z1, and t is lying between 0 and 1. Here x1, y1, z1 is a starting point of the straight line segment, and x2, y2, z2 is the end point of the line segment. Means this is the starting point from where you start working or start moving, and this is the end point where you end your working. Next, after knowing these basic things, we will move on question number 14 of exercise 16.1 from Thomas Calculus 12th edition book. Here, what is the requirement? Find the line integral of this function f of x, y, z is equal to square root of 3 divided by x square plus y square plus z square over the curve r of t is equal to ti plus tj plus tk, and the limits of t are 1 to infinity. So in step number 1, Please note that R of t is actually xi plus yj plus zk. If you compare these two equations, the value of x is t, the value of y is t here, and the value of z is t. So in the next step, after knowing this thing, we can calculate the derivative of R of t. The derivative of R with respect to t is 1i plus 1j plus 1k. Because the derivative of t with respect to t is 1, I remain as it is. Derivative of t with respect to t is 1, j remain as it is, plus derivative of t with respect to t is 1 and k remain as it is. After this, we can calculate mod function v of t mod by calculating the modulus of dr over dt. Now, in order to calculate modulus or mod value of a given vector, we have I component square plus j component square plus k component square whole square root. Here we have taken the coefficient of I, j and k here, taking its square, adding them, and then we will apply the square root. So we get square root of 3. So value of v of t mod is square root of 3. Now in the step number 2, we will convert our force function or our given function in the form of t. From here, as I have told you in the beginning, when we compare these things, the value of x is t, the value of y is t, and the value of z is t here. So we will substitute the values of x, y, and z here. So I got square root of 3 over t square plus t square plus t square. And after simplification, I have square root of 3 over 3t square. So step number 1 is completed. Step number 2 is completed. In step number 3, we will substitute these values in the formula of line integral, and then we will evaluate our required line integral. Now I have simplified the formula of line integral as integral over the curve C f of x by the ds is equal to limits from a to b f of r of t. Means we will convert our force function with the help of r of t into v of t mod dt. In this question, the value of f of r of t is square root of 3 over 3t square. The value of v of t mod is square root of 3 dt. In the next step, we will evaluate this integral. Square root of 3 into square root of 3 is 3, and 3 and 3 will be cancelled out. So I have 1 over t square, and I can write t square as t raised to power minus 2 so that I can perform the integration. In the next step, integrating this function t raised to power minus 2 with the power formula, I got t raised to power minus 2 plus 1 over minus 2 plus 1. So its answer is minus 1 over t. In the next step, applying the limits with the help of fundamental theorem of calculus, upper limit minus lower limit. When we will apply upper limit, 1 over infinity is 0 and 1 over 1 is 1. So our answer is 1 after simplification. And this completes the step number 3 and our required question. Next, it is question number 15. In question number 15, what is the requirement? Integrate f of x y z is equal to x plus square root of y minus z square over the path from 0, 0, 0 to 1, 1, 1. Here it is the path, C1 path, and this is the C2 path. Means if you have to move from 0, 0, 0 to 1, 1, 1, first of all, you will move along the path C1, and then you will move along the path C2. For both paths, limits are given to us 0 to 1. In the next step, we will evaluate this problem. And for this purpose, first of all, we will perform our calculation with respect to the path C1. Then, after completing the calculation with respect to C1, we will calculate the line integral with respect to C2. And in the end, in order to calculate total line integral from 0, 0, 0 to 1, 1, 1, we will calculate the line integral along the path C1 and plus along the path C2. So step number 1, R of t is given to us, taking its derivative for curve 1. Derivative of t with respect to t is 1, derivative of t squared with respect to t is 2t, and derivative of 0 is 0. In the next step, taking the mod, I component square plus j component square, and 0 square is 0 actually. So I got 1 plus 4t square whole square root. Next, in step number 2, we will transform our force function in the form of t. Here, please note that the value of x is t, the value of y is t square, and the value of z is 0. So substituting these values, I have t plus t square root minus 0. Making the simplification, I got f of r of t is equal to 2t. So after completing step number 1 and step number 2, we can evaluate the line integral along the path C1. So line integral along the path C1 is 2t into 1 plus 4t square whole square root. Now, in the next step, we will apply this formula. And what is this formula? If we have a function with some power and derivative of function is available as a multiplier in the integrand, then we will integrate the function by adding 1 in its power and then dividing with the same number. So we will apply this formula here in order to integrate this one. So rewriting, and then please note that the derivative of 1 plus 4t square is 8t and we have only 2t. So in order to complete this derivative, I have multiplied with 4, and in order to balance it, I have divided with 4. Now you can see the function inside the power, that is 1 plus 4t square, has its derivative 8t as a multiplier. So in the next step, we can apply this formula to integrate it as 1 by 4 remain as it is, 1 plus 4t raised to power 3 by 2 over 3 by 2. We have added 1 in the power and divided with the same. Now in the next step, this 2 will balance out this 4 and we get 1 by 2, and 1 by 2 into 1 by 3 is 1 by 6. And we have also applied the limits, upper limit minus lower limit. So I got 1 plus 4 raised to power 3 by 2, which is actually 5 raised to power 3 by 2, minus 1 plus 0 raised to power 3 by 2 is 1. So 5 raised to power 3 by 2 is 5 into square root of 5, which is calculated as 5 raised to power 3 by 2. We can write it as square root of 5 raised to power 3. Now, if you have power 3, it means you are multiplying that particular term 3 times. So we can write it as square root of 5 into square root of 5 into square root of 5. First root square root of 5 will become 5 here into, and this square root of 5 remain as it is. So the answer of 5 raised to power 3 by 2 is 5 into square root of 5. Now we call this equation number 1 or line integral number 1. Next, in question number 15, we will perform our calculation for the second path C2. For C2, R of t is given to us I plus j plus tk. Here the value of x is 1, the value of y is 1, and the value of z is t. Taking its derivative, we got 0i plus 0j plus 1k. Calculating its mod, we get v of t mod equal to 1, I component square plus j component square plus k component square whole square root. So step number 1 is completed. In step number 2, we will transform our function in the form of t. Please note that the value of x is 1, the value of y is 1, and the value of z is t. Substituting the values here and then making the simplification, we got 2 minus t square. So step number 2 is completed here. In the next step, we will use these two values to calculate the line integral along the path C2. Now substituting the values, I got 0 to 1, 2 minus t square into 1. Integrating, the integration of 2 is 2t, minus integration of t square is t cube over 3. In the next step, applying the limits, I got 5 over 3. So this is the answer of line integral along the second path. In order to calculate line integral along the whole path, means C1 and C2, we will add the results. So after adding the results, I got 1 by 6, 5 square root of 5 minus 1 plus 5 over 3. Opening up the brackets, I got 5 square root of 5 over 6 plus 3 by 2, which is our required answer. Next, please note that question number 16 is similar to question number 15. There is just difference of R of t there. So I am moving on question number 17. You will do it by yourself. You will do question number 16 by yourself. So what is question number 17? Integrate this function f of x, y, z is equal to x plus y plus z divided by x square plus y square plus z square over the path r of t is equal to ti plus tj plus tk for the limits a to b. So in step number 1, r of t is given to us, taking its derivative with respect to t, dr over dt. We got derivative of t is 1, derivative of t is 1, and derivative of t is 1. So we got I plus j plus k. In the next step, calculating v of t mod. So I coefficient square plus j coefficient square plus k coefficient square whole square root. 1 plus 1 plus 1 will give us square root of 3. Step number 1 is completed. In step number 2, we will convert our force function in the form of t. Please note that here the value of x is t, the value of y is t, and the value of z is t. So substituting the values, we got t plus t in the numerator, and in the denominator we get t square plus t square plus t square. Making the simplification, we got f of r of t is equal to 1 over t. So after completing step number 1 and step number 2, we can move on our calculation of line integral as, now substituting the values, limits from a to b, the value of f of r of t is 1 over t, v of t mod has the value square root of 3 dt, and limits are a to b. Integration of 1 over t is natural log of t for the given limits. In the next step, applying the limits, upper limit minus lower limit, we have square root of 3 into natural log of a minus natural log of b. In the next step, we can apply the property of natural log. So we have square root of 3 into natural log of a minus b as square root of 3 into natural log of a over b. And this is our required result. Now, after this is question number 18. Integrate f of x, y, z is equal to minus square root of x square plus z square along the circle r of t is equal to a cos of t j plus a sin of t k. So in step number 1, r of t is given to us. We will take its derivative with respect to t, and then after taking the derivative, we will calculate v of t mod. V of t mod is calculated as I component square plus j component square plus k component square. Since we don't have any I here, it means the coefficient of I is 0. So making the simplification, we can take a square common. So we got sine square of t plus cos square of t. Now sine square of t plus cos square of t is 1, and a square square root is equal to mod of a. So step number 1 is completed here. Step number 2, we will convert our function in the form of t. Please note that in r of t, we don't have the coefficient of I. It means the value of x is 0. The value of y is a cos of t, and the value of z is a sin of t. So substituting the values, x equal to 0 and z is equal to a sin of t. From here, we got minus a square sin of t, and in the end, after applying a square square root, we got minus mod of a sin of t. So step number 2 is completed here. In step number 3, we will substitute the values of f of r of t and v of t. So we got minus modulus of a sin of t into mod of a dt. Now we can take mod of a outside with minus sign, and we are left with limit from 0 to pi sin of t dt. Now please note that we cannot integrate sin of t directly here because the behavior of sine function is different for the given limits. Sine function is not continuous for the given limits 0 to 2 pi. Its behavior is different in the first two quadrant, and its behavior is different in the third and fourth quadrant. For in first two quadrant, that is for the angle 0 to pi or 0 to 180, sine function is positive, and then for the angle greater than 180 up to 360 degree, sine is negative. So we have to break the limits accordingly. So in the next step, we have broken the limits, limit from 0 to pi. So we get for the positive 0 to pi, we get positive sine of t, and then pi to 2 pi, we are getting minus sine of t. In the next step, making the simplifications, we have minus a mod square, limit from 0 to pi sine of t minus pi to 2 pi sine of t. Now the integration of sine is minus cos of t, so we have minus cos of t for the limit 0 to pi minus into minus cos of t limit from pi to 2 pi. In the next step, applying the limits after making the simplification, we got cos of pi minus cos of 0 minus cos of 2 pi minus cos of pi. Now the value of cos of pi is minus 1, the value of cos of 0 is 0, and the value of cos 2 pi is 1, and the value of cos of pi is minus 1. So after making the simplification, we get our answer as a square mod into minus 2 into minus 2. So minus 2 is minus 4. So our answer is minus 4 a mod square. I hope you have understood this question. Please like, subscribe, and share this content with the students or with the fellows. Allah Hafiz.